Okay, so next thing, calculate the values of x for which fx and gx between that domain have the same gradients. Okay, so if we're talking about when they have the same gradients, that means that we want fx to be equal to gx. Okay, it has to be between these two things. Now, the first thing that we want to check is what is your calculator in? So here, this and this are actually radians. Now, the reason I know that is because we have radians is standard, that's the normal one. Degrees is the weird one. So if you're not told that it is in degrees, then you leave your calculator in radians. Okay, so first things first, let's calculate the derivative. Is equal to, so the first one, derivative of the inside of this is 3 over the original function that was there. And gx is equal to derivative of the inside of this bracket, so a half times -4 will give me -2. Cos goes to minus sign, so that'll become minus sign times -2 makes for the +2, and then we just put our bracket back in, same way that it looks here. Beautiful. Okay, so there's two ways to solve this. First way, I'm going to chuck it into our solve n function. Now I'm using solve n just in case there's multiple solutions. So option, calc, solve n, 3 over 3x minus 2 is equal to 2 sine 0.5x. Tell it what letter you're solving for, comma x. Close that bracket up, press equals. Okay, like I said, more solutions will exist. So go up here and then we're going to scroll across to the ones that fit our domain. It's currently... Uh-oh. Well, now look what you've done. Okay, let's try that one more time. Otherwise, I'm going to put it on the calculator that I have next to me and get my solutions that way. Or I just didn't like it when I held down the button. Okay, so the ones that fit in the domain, 1.429 and 6.098. So x equals 1.4295 and 6.098. Now round these to two decimal places equals 1.43 and 6.0. Well, that will make that round up, so it'll be 6.10. Now, the other thing that I was going to show you is how could you solve for this using, first things first. If your calculator was in degrees, you wouldn't get these answers. But if you showed on here what you'd put in the calculator, you would get partial marks for the working. So make sure that you're always writing down whatever you put in the calculator, just jot it down on the paper as well. It's worth the time. Now, the other way we could have solved this is graphically. So again, I would take the derivative of both functions, and then I would type it in as the new function that it is. Execute, my other function is 2 sine 0.5x, close your bracket, execute. Now, that is the functions for the gradients. We want when they're equal, which means that on our graph, it's going to be the points where they're touching. Scroll down. Now, my one isn't showing a very nice picture because it's just really zoomed out. So there you can see we've got a couple of points of interception. I can G-solve for them. And that's going to be where the gradient is equal and we want the x value. So intersection points, that's out of our domain. That's out of the domain. That's in the domain. There he is, 1.4 and 6.98. So that's how you could solve graphically.